In this video, we will learn about the linear search algorithm and how to implement it using C++ code. A linear search is when we are searching for a particular target item in a collection of items, and we go through those items one by one. If we find the item, we return its index, aka its position in the collection. In the event that we've iterated over all of the items in the collection and haven't found the target we are looking for, we return -1 to indicate that the item is not in the collection. For example, let's say we have a vector containing the elements 2, 10, 5, and 7. We will pretend that we are looking for the target element 5. A linear search would go through each element in the vector, so it would check 2. Since 2 does not equal 5, we progress to the next number, which is 10. Since 10 does not equal 5, we move to the next value. This value is 5, which is the target element we are looking for. We will return the index or position of 5 in the vector. Since indexing starts at 0, 5 is at position 2 in the list, so we return 2. Let's say that we were looking for the element 6. Our program would go through each number in the vector and check if it was 6. Since our collection does not contain the number 6, the program would return -1. Now that we understand the concept of the linear search algorithm, let's learn how to implement the logic using C++ code. Up at the top of the program, we will include the vector header file. After that, we will create a function that returns an integer named linear search. It will take in two parameters, a vector of integers named list and an integer named target. Inside of our linear search function, we will use a for loop to iterate over each element in the list. For int I equals 0, while I is less than list.size, and incrementing I each time, we will use an if statement and check if list at index I is equal to the target. If this is true, we will return I, which is the index of the element in the collection. At the bottom of the function, outside of the for loop, we will return -1. This is because if the code hits this point, it means that the target element was not found in the list. Time to test our function. Let's go inside of C++'s main function. Inside of here, we will create a vector of ints named numbers. We will add the integers 2, 10, 5, and 7 to the vector using the pushback function. After that, we will output the result of a call to the linear search function with numbers passed in as the first argument, and 5 passed in as the second argument. When we run the code, notice that 2 was output to the console. This makes sense, since the element 5 does exist in the list at index 2. In this video, we will learn about the binary search algorithm and how to implement it using C++ code. First, let's understand conceptually what a binary search is. A prerequisite for the binary search is that the list being searched through needs to be sorted in order for this algorithm to work. So if you are given an unsorted collection on a coding interview, then you will need to sort it first before utilizing the binary search algorithm. With a binary search, the middle element is checked to see if its value matches the target. If it does, we return the midpoint, the index of the middle element. If the target we are looking for is higher than the current element we are on, we will make the minimum value the midpoint, since we now only need to check the second half of the list. Conversely, if the target is less than the current element, we will make the maximum value the midpoint, since we know that if the element is in the list, it would have to be in the first half. We then recalculate the midpoint by adding the minimum and maximum values and dividing by 2. We then repeat the steps we described until we either find the element we are looking for, or the min and max values are equal. If the algorithm completes without finding the target, we return a value of -1. I know binary search can sometimes be tricky to understand when first learning it, so let's look at an example before we jump into coding it. Let's say we have a vector of the integer values 1, 2, 3, 4, and 5. The values in the collection are sorted, so this is a great candidate for the binary search algorithm. Pretend we are looking for the number 5. We will start out at the middle element, which is 3. Since 3 is less than 5, we only need to consider elements in the right side of the collection. Therefore, the minimum value is 3, and the maximum value is 5, and the middle element is 4. Since 4 does not equal 5, we repeat the steps for everything to the right of 4, which is just one element, 5. We have found the element 5, which is at index 4 in the vector, so we return 4. Now that we've looked at an example demonstrating the theory of the binary search algorithm, let's learn how to implement it using C++ code. Up at the top of the program, we will include the vector header file. Next, we will create a function with an integer return type named binary search that takes in 2 parameters, a vector of int named list, and an int named target. Inside of this function, we will have an integer variable length that we set equal to the size of the list divided by the size of the item at index 0 in the list. Recall from earlier in the course that size of gives us the size in memory. So by dividing the size in memory of the total list by the size that one element in the list is taking up in memory, we can figure out how many elements are in the list. Then we will have an int variable min set to a value of 0, an int variable max set to length minus 1, and an int named midpoint that we set to length divided by 2. While min is less than max, we will have an int variable named current set to list at index midpoint. If current is equal to target, this means that we have found the number we are searching for in the list, so we can return its position, which is midpoint. Else, if target is greater than current, we will set min equal to midpoint. Else, if target is less than current, we will set max equal to midpoint. At the bottom of the while loop, outside of the if and else if statements, we will set midpoint equal to min plus max divided by 2. Outside of the while loop, we will return -1, since if the whole while loop executes and we have not found the element, we know that the collection does not contain the target element that we're looking for. That wraps up our binary search function. Let's test it out. We will go inside of C++'s main function and create a vector of integers named numbers. Let's add the elements 1, 2, 3, 4, and 5 to our numbers vector using the pushback function. After that, we will output the result of a call to the binary search function with numbers passed in as the first argument, and 5 passed in as the second argument. When we run the code, notice that 4 was output. This is correct since the element 5 is at position 4 in the collection.